We will wait for 5 minutes until everyone joins. Hello? Yeah, only 9 participants have joined the meet. Where are the others? Like, you guys call your friends and ask them also to join the meet. Hello? Yeah. So it's 4:35 and it's already late. So I guess we should start the session. And I just share my screen. Is my screen is visible? Hello? Hello? Guys, try to be interactive. You can just chat, like just write a message in chat box if anyone wants to. Hello. Okay. So shall we start? Okay. So hello everyone. So our today's session will be on microcontrollers. So today we are going to see different types of microcontrollers with details. So we'll go slowly today. I will explain every small detail to you about microcontrollers, like which are the common microcontrollers, or like what are the usage of microcontroller, why we use this microcontrollers only. So yeah, before starting today's session, uh, I guess yesterday uh, my friend Ankit Kriti has given you a task like to interface the LCD with Arduino Uno. So anyone has tried that task? It also told you to interface the temperature sensor also. So anyone try the task? Hello? No one tried that thing on Tinkercad? Anyone? Please reply. Omkar, Hima, Akash. Did you guys tried that assignment? See, if you tried, just say yes. And if you haven't tried till yet, like now, you can just say no. There's no problem. Like you can try that thing today also. Okay. Okay. And what about others? Okay. Okay. So I have to give you guys an update. Like you have to submit. You can just submit this. You can just try this experiment by today and submit this on our WhatsApp group as well. Will this assignment will be completed by today? Okay. So once it is completed, like you can just submit the output in our WhatsApp group. Okay. Okay. So we'll start with our today's session. So, yeah, our today's session is on microcontrollers. So any one of you like know like what is microcontroller and why we use microcontrollers? Anyone? Did you guys hear the name microcontrollers? Or you guys know like any common microcontroller we have? See, just if you know, just say yes. Otherwise, say no. No issue. Anyways, I'm going to tell you like the whole detail of microcontrollers. Okay. I guess the answer is no. Okay, so yeah, so let's start the session. Uh, so basically, a microcontroller is a compact and self-contained computer system that is designed to perform a specific task, or like we can say control specific functions in electronic devices. It is essentially you can say like it is essentially a small computer on which a single integrated IC is used. So you guys know what is IC? So basically, IC is an integrated circuit where we have interface like connected different kinds of like what components and make that to make a particular chip compact. Okay, so these microcontrollers are widely used in various applications, which is ranging from simple households appliances to complex industrial automation systems. Then we'll see one by one. Okay, so basically the key character. Let's see the key characters first. So basically, the key characteristics of microcontrollers are like every microcontroller has a processing unit of memory, for storage and RAM, then input output pins, then clock source, peripherals, etc. So there are several common microcontrollers we are going to see today. The first one is Arduino Uno. Do you guys know what is Arduino Uno? Anyone know what is Arduino Uno? Hello. Guys, please reply. Any one of you know like what is Arduino Uno? Yes or no? Okay. So see, Arduino is a microcontroller. Like basically, it is a popular microcontroller which is based on a chip called Atmega 328P microcontroller. Okay, so it is a like most popular microcontroller which was used worldwide. So this microcontroller is designed for easy prototyping of like DIY projects, like do-it-yourself projects. Uh, so are you able to see my screen? Like you're able to see the diagram, no? Here we'll see like the pins one by one. Okay. So first of all, I will just tell you like this Arduino Uno has you can see there is one Atmega 3280 microcontroller. Okay. So the Atmega 3280 microcontroller it is a 8-bit AVR microcontroller which has a 32 KB of flash memory. 32 KB of flash memory means we can flash like up to 32 KB code in this microcontroller. Then it has a 2 KB SRAM, like the static RAM. SRAM stands for static RAM. So basically, and 1 KB of EEPROM. Okay. So basically, this storage is for like inputting the code in this IC and for running the code using this IC. So this storage and the RAM is for storing and running the particular code in this microcontroller. Okay. So is there any doubt with Atmega 3280P? So like, the Atmega 3280P is the common chip, like common IC, which is used in Arduino Uno also, and as well as Arduino Nano. Like you guys know like computers. So can anyone tell me like which is the main component of computer? Like there is monitor, there is CPU, there is mouse, there is keyboard, there is like printer, etc. So can anyone tell me like which is the main component of the computer, like which runs all the thing? Which is the main component of the computer system? Anyone? See, it's a simple question. Yeah. So basically, yeah, motherboard. Okay. So basically, this Atmega 3280 microcontroller is kind of motherboard. It controls all the functionality of this board. Okay. Like whether we are taking an input, whether we are giving an output, whether we want to like uh, turn on an LED, we want to communicate with other sensors. The Atmega 3280 is going to control everything in this board. Understand? Hello. You guys understanding what I'm saying? Like if any one of you has doubts, like okay, others, like what about others? If you guys have any doubt, like you can just ask. I mean now only. I can clear your every doubt. I'll try to clear your every doubt. Are you guys having any doubt for the Atmega 3280 microcontroller? Okay. See, if you are not going to reply, na, you guys are not going to learn anything. Okay. Omkar is saying understand. Okay. Okay. Let's see the other pins. So we'll start from the left side. So yeah, the first one is like the Type B USB connector. Okay. So basically the Type B USB connector is used like there are two functionality of this connector. Like either we can give supply to this board using the Type B USB connector with your like PC or like power bank or something, or else we can use this Type B USB connector to like dump your code uh, into the Atmega 3280 IC. Then we have a Atmega 16 USB to serial IC here. So as uh, like this basic IC is used to convert the USB to serial. So basically what we are doing is like first we are connecting the Type B USB connector to here. Then whatever the code we are dumping here, like it is going to convert from normal USB to serial for the serial communication using this IC. Then we had a DC jack, DC barrel jack connector. Here, from the DC barrel jack connector, we can also power the board using a 9 volt supply as well. Then we have a reset button here. So let's see the reset button later. Here you can see different pins. Like there are first of all there are analog pins. So yeah, yeah. So one second, guys. Hello? Yeah. As you can see, like there are analog inputs, then there are digital inputs. So we can the input and output should be like digital and analog. In Arduino, there are total 6 analog inputs, and there are total uh, first of all, analog inputs. This pins can read only analog voltage levels. Uh, you can say, like from 0 to reference voltage, like anything. Usually, it is for 3.3 volts. Okay. Or we can say like 0 to 5 volt. Then the analog pins have like 10-bit ADC converter, which is analog to digital converter. So if I connect some analog sensor to this analog pin, it will directly convert the analog data to digital data, because uh, no microcontroller works on like analog data. You have to convert the analog data in digital data first, and after that only the IC is going to process that whatever. So you guys know like what is digital signal? Can anyone tell me like what is digital signal? Anyone? Okay. So basically, the digital signal is like 0 or 1, like true or false, on or off. Okay. So there are several like sensor which only works on analog signal. So for those sensor, we use this analog pins. So you guys tried the potentiometer? No. So to get the potentiometer, like which pin we have used? Does anyone of you remember that? For potentiometer, like we connected the potentiometer in which pin? Like is it digital or analog? Any one of you remember like which pin we have used for potentiometer to connect in potentiometer? Hello. Yeah, sorry for the interruption. Let's continue our topics. So, as I asked you a question, like any one of you remember like which pin we have used for getting the input from analog, like potentiometer? Any one of you? Okay, so we have used the analog input. Okay. Then, as you can see, there are different pins. Like there is V in pins. Then there is a ground pin. Like from V in, like the V in pin will give us the 5 volt output, as well as also we can also power this board using the V input pin. Then there are two ground pins here. Then we have two power output pins. Like one is 5 volt and another is 3.3 volt. So the 5 volt provides us with the voltage of 5 volt, and the 3.3 volt provides us the voltage of 3.3. Okay. Then there is a reset pin here. So the reset pin is for like if I dump any code in the like in the Arduino Uno board. One second. Yeah. If we dump any code in the Arduino Uno board, so if you want to reset the board, there are two ways to reset a particular board, from which we can just reset the code. Like we can just reset the loop of the board. The first option is like we can just apply an input in the reset pin, or else we can use the reset button. Are you clear? Hello? Am I clear about this thing, like reset button? Hello? Okay. Then we have a serial TX RX pin. So this, like every microcontroller has like different types of serial communication protocols. So one of them is like UART, then second one is I2C, and third one is SPI. Okay. So first we will see like the UART one. Uh, so for in the UART communication protocol, we use two pins. Like one is TX pin and one is RX pin. So the pin number, digital pin number 0 and 1 are the default TX-RX pins. Uh, so the TX pin is used to transmit the data from the Arduino to like transmitting the data from Arduino to any sensor or device. Like with what do you say? Like if I want to communicate with a sensor which has a TX-RX pin, so I will connect the TX pin of the Arduino Uno board to the RX pin of the sensor, and I will connect the TX pin of sensor to the RX pin of Arduino Uno board. Okay, to complete the cycle of communication. Just see that chat box. This kind of connection we have to do to to complete the completion cycle uh, of the UART protocol. We have to connect the TX to RX pin and RX to TX pin. So if we are using a sensor which works on the UART protocol, and we have an Arduino board, we'll connect the TX pin of Arduino to the RX of the sensor, and TX pin of the sensor to the RX pin of Arduino board. Understand? Hello? Like if you guys have any issue, like please ask. If you are not understanding, just tell me. Like I will understand once again. Hello. Okay. Then the second communication protocol is I2C. As you can see here, this is the I2C protocol. So for I2C protocol, the two pins which we use is SCL and SDA. These are the two pins which we use for I2C communication. So like there are sensor which works on this device. Like if you guys know like what is OLED, there is an like OLED screen, which is the working of that particular screen is like more like the LCD screen, but that particular OLED display works on the I2C protocol. So if you want to use that particular OLED display, we had to communicate. We had to connect the SCL and SDA pins to that particular display. So this is the another kind of communication protocol. Here here the connection will be like uh, SCL to SCL and SDA to SDA, as you can see in the chat box. In the UART communication protocol, we have connected the TX to RX and RX to TX, but here we are connecting the SCL to SCL only and SDA to SDA only, like SCL of microcontroller to SCL of like sensor, and the SD of microcontroller to SD of sensor. Am I clear? So there is another protocol, like which it's called SPI protocol. As you can see here, the IC SPI protocol. So in the SPI protocol, there are several pins like MOSI pin, MISO, like master. MISO means master input, slave output. Then MOSI means master output, slave input. Then we use a VCC ground and clock pin as well. So there are some sensor which works on this protocol. So we use these connectors to communicate with that particular sensors. Then there are some LEDs given in the microcontroller to display the something like there is one inbuilt LED is given, like which is directly connected to D13 pin. Then there is a power LED. If you power the microcontroller, the LED starts blinking. Then there is one TX RX LED. So whenever you are using the UART communication protocol, if the data is transmitting, this LED will start blinking, the TX one. And if the microcontroller is receiving any kind of data to its RX pin, the RX LED will start blinking. Understand? Okay, I will show you. Okay. See, this is a complete pinout for Arduino Uno. So in the left side, you can see there are 6 analog pins like A0, A1, A2, A3, A4, A6. Okay. So this is the pin number of the particular Uno board. Beside that, like there are some numbers like PC0, PC1, PC2. Okay. So this is the number of the pinouts for the Atomic IC. That my IC which we are using in the Arduino Uno board. this is the pin number of that particular IC. So basically, the TC0 pin of the Atmel 328P IC is connected to this A0 pin, from where we are getting the input, like getting input or output. Okay. Then, so there are like inbuilt ADC converters, which converts the like whichever data you are giving input in analog pins. The ADC converter is directly converting that data into digital format using the ADC converter, like, which is analog to digital converter. Here, the SD and SCL pins, we already told you, like, can the SD and SCL pins. Can anyone tell me like what is SD and SCL? Like, which communication protocol is use the SD and SCL pins? Anyone? Just tell me like which protocols uses the SD and SCL pin. Hello, Gura Pajala Dinesh, Siddhantapu, Omkar, others? Anyone? I just want to tell you like there are different protocols. Like there are three kind of protocols, communication protocols. Can anyone tell me like which protocol uses the SCL and SDA pins? Whether it is SPI, whether it is UART, or whether it is yeah, I2C. Which protocol? This means you guys are not understanding anything. See, well again explain you this thing. Second. I'll just quickly revise this thing. The Arduino board has different pins. Like there are digital pins, which are configured as digital input or output. So they can just read digital signals like high and low from like external sensors, switches, or other devices. Then they can be used to send digital signals and get digital signals. Then there are analog pins. These pins can read analog voltage levels ranging from 0 volt to 5 volt. So, and these pins have like ADC converters inbuilt to convert analog data to digital data. Then these analog pins are useful for reading like different sensors. Then in this microcontroller, we have different kinds of communication protocol. One is UART, another one is I2C, and third one is SPI. In UART, we use a TX and RX pin for communication. In UART, we connect the TX to RX of the sensor. Then we connect the RX of the microcontroller to TX of the sensor, which we are interfacing. In I2C, we use the SCL and SDA pin, which is like the SDA is the A4 pin, which is analog A4 pin, and the SCL is A5 for analog purpose. And here the SCL and SDA pins are on the left, on the right top corner. These pins are used for the I2C communication through buses. And the third one is SPI, which uses the MOSI and MISO pins for communication. Like here you can see the MISO and MOSI pins. So generally, the overall the Arduino Uno microcontroller has like from digital pins ranging from D0 to D13, which is like 14 pins, 14 digital pins, and A0 to A5, that is 6 analog pins. It has different power supply in like power supply outputs. Like one is 3.3 volt, then 5 volt, then V. Also, and there are several ground pins also as well. We can just reset this uh, Arduino Uno board using either we can use the reset pin, like we can just give input to the reset input, or we can just use the reset button, which is given in the Arduino Uno board. Any doubts? Hello. Like if you guys have any like similar doubt, like silly doubt also, like you can just ask. There is no issue. I will just okay. So I guess no one has any doubts. Okay, so let's move to the another board, which is Arduino Nano. So this is the like we can say like the Arduino Nano is the compact version of the Arduino Uno board. This this Arduino Nano board also uses similar like use the same IC, which is Atmega 3280p, as you can see here. So this is the Atmega 3280p IC. Here, the size of the particular IC is reduced. Like to make this particular board compact, we are using a compact Atmega 3280p IC. The pinouts of the particular IC will be same, but only the size has been reduced. So let's see the physical overview of this particular. Yeah. So this Arduino Nano board has a mini B USB for either programming the board or to power the board. Then here, one second. Yeah. So here as well like there are several analog pins given like A0 to A7. Then there are digital pins are given like from D2 to D12. Here there is one D13 pin is also given. So there are in total like there are like 14 digital pins here also. Like if I say like the digital pins are ranging from 2 to 13. The two starting two pins like D0 and D1 are used as the common pins. Like then we have a 5 volt pin which supplies the 5 voltage to us. Then there is one reset pin, ground, V. the functionality of the pins will be same as the Arduino Uno, as we are using the same board, but only compact version. So the communication protocol, the working of pins will be the same. And yeah, this is the reset button here to reset the pins, and these are the indication LEDs. Like whenever we are receiving or transmitting something, these LEDs will glow or power, giving power, or the D13 LED. Anyone has doubts still here? Hello. Like, if anyone wants to unmute themselves, they can unmute. Like you can just have a conversation. I know these things are new for you, like, but until you guys like unless you interact with me and ask questions, like whichever doubts you have, you're not going to learn anything. Okay, so let's yeah. So also, as you can see, like there are pins ranging from like D2 and D12. Okay, so some of the pins, like there are some pins like D3, D5, D6, D9, D10, and D11. So basically, these pins are yeah, these pins can work as pins also. So now you guys will ask like, what is PWM pins? So yeah, this is the pinout for this Arduino Nano. The connections are like pretty much same only. So as you can see, like the D3 pin, this D3 pin, D3, D5, D6, D9, D10, and D11. These pins are also known as like PWM pins, that is pulse width modulation pins, because like these pins can simulate analog output by using pulse width modulation. Uh, if you are giving an output from these pins, you can get like you can get an analog output by using a like technique which is called pulse width modulation. This pins also allows you to like use this pins also allows you to control the average of the voltage supplied to a component. Like if I supplied some kind of voltage to a component which is interface to this uh, Arduino Nano or Arduino Uno board. So with the help of this PWM pin, we can just average that, or we can just control the supply which we are supplying to this sensor. Like if I connected some LED to this board, I can be able to control the brightness of the particular LED. Like as you know, like we can control the brightness of the LED, or we can control the speed of the motor using a potentiometer. So okay, there is some like doubt. Sir, I have doubt that we need to take this, I think all this from Tinkercad. So the answer is like, you don't need to take all this to Tinkercad. You can just use the normal Arduino Uno board. But the thing is like, until you don't understand the full function of these pins and all, you will be not able to like interface the sensor to this thing. Like if I told you to like interface a sensor which works on the I2C communication, until you know this until you know this I2C communication protocol, you will be not be able to interface that particular sensor. Or if I told you to interface one sensor which works on this RxTX pin, which works on the UART thing, until you know that you have to connect the TX pin to the RX of the sensor, will be not able to implement that particular thing in your project. So these things are only for your basic knowledge. So whenever you are going to implement anything in your project, you'll be able to interface any sensors with your like made any connections to this uh, with your board, your microcontroller board. Are you understanding? So the thing is like until you don't understand like how the microcontrollers are working, you won't be able to use that particular microcontroller. No. Let's say if I say like you the sensor you're using is analog, but you don't know about analog and digital pins. So you will try to connect that particular sensor and digital pins, and it will not connect properly, and it will not give you values. That's why the basic knowledge of Arduino, Uno, or Arduino Nano, or any other board is like necessary. Understand? Okay. Okay. So these are the all pins, like basic pins. If anyone has doubt in these pins, like any pins, whether it will be analog pins, whether it will be like default pins, interrupt like communication protocols, like uh then the power supply, then ground, anything. You can just ask, like you can ask in chat box also. Either you can ask in chat box or by inviting yourself. No one has any doubts. Okay. So if no one has any doubts, I will just ask few questions. Like you, if you guys are understanding everything, you will be able to answer the questions. Okay. So just tell me, uh, like why this ADC is used? Like why we use this ADC? Akash, unmute yourself or just write in chat box why we use this ADC. P. Venkat, S. Navya, tell me why we use this ADC pins. What is the use of this ADC pins? Surya Teja, Venkata Sai, Varun, Omkar, Siddhant Appu, no one? Okay, I guess no one is understanding anything. Like, okay, so now we will stop our session. Like now only. Your today's task is to like you had to uh learn everything, like search anything on Google about this Arduino Nano and Arduino Uno. Like whatever I told you, like what are digital pins, what are analog pins, what is the use of ADC. Just go through this stuff. Tomorrow we will learn about the other microcontroller like ESP32 and ESP8266. So then I will ask you about this question. Ask you a few questions about this, like Arduino Uno and Nano. Will you guys go through this by today by yourself only, or shall I explain you once again? If you want me to explain right now, I can. Anyone? Okay. So like I'll just give it a quick through like this Arduino Nano and Arduino Uno one more time. See, first of all, you will see the power buttons. Okay, like power pins. So the power pins are marked with the red color. Okay, here you can see like the power is like 5 volt. This pin gives us the power of 5 volt. Okay, as an output. Then there is one more output like 3 with 3, which gives us the output of 3.3 volts. Here there is one VIN pin, which where we can give an input to this particular microcontroller to function for the functionality, and as well as we can also get like output from this pin of 5 volt. Then here you can see like this pin also provides us these are the ICSP pins. This pins also provide us the 5 volt. Then there are ground pins which are colored as black. So these all are the ground pins, like the negative ones. If you connect the LED, we'll connect the positive terminal to 5 volt and the negative terminal to ground. Then there are digital pins. All the digital pins are colored in uh, like brown color. Then these are all the digital pins on. Then there are analog pins which range from A0 to A7. There are total 8 analog pins. Then the green color pins are communication pin. Like the SD, SCL is for the I2C communication. Then there is SCK, MISO, MOSI, SS pin for SPI connection, SPI communication protocol, and the RxD and TXD pin for UART communication. Then there are microcontroller pins. As I already told you, this number are of the microcontroller pins, like 8 mega 3280 pin numbering, like these are the pin numberings, like PC0, PC1. So the PC0 of 8 mega 3280 is connected to the A0 of this board. Then there are default pins, like there are default ADCs there, like A to D, like analog to digital converter, which converts all the analog inputs to digital output, which will be processed in the Arduino Nano board in the 8 mega processor controller. Then the green ones are the timer pins, which is used for the clock ones. as they are not that useful, that much useful for your work, then there are some other pins like there is one interrupt pin, then there is one analog pin, but these pins are not used in our normal embed C coding. Okay, any doubts? Anyone? Okay, if no one has any doubt, like we will stop this session right now. Your tomorrow's task is to learn about this Arduino Uno and Nano microcontroller, like uh, what are these pins and all. Whatever things I have told, like basic things like digital pins, analog pins, why we use digital pins, why we use ADC, like analog to digital converter. What is the difference, like different commission protocol, that is I2C, UART, and SPI. I will ask few questions tomorrow on these things, and also we'll learn about different microcontrollers tomorrow. Okay. So thank you everyone for joining.